Hi everybody, welcome to my new channel. I will be doing mathematics from grade 10 to grade 12 on all different levels, reteaching and reinforcing and moving into more difficult examples for those of you who need it. And I hope that you will find something very beneficial from what we are about to do. Let's get started. Right, we're going to do some past paper exam questions. This one says, if sine of x plus 30 degrees is equal to a half sine x, prove that tan x is equal to 1 over 1 minus root 3. Now, with the word prove, this is not an identity. Here is an equation. We're not trying to prove left-hand side equal to right-hand side. Here is an equation, and we're going to do the equation, and they've told us that will be our answer. Right, so going with this, we're going to do special angles once we have done the compound formula. Right, and then I'm going to equal, sorry, this is not left-hand side, right-hand side, half sine x. Okay, cos of 30 is root 3 on 2 sine x plus sine of 30 is a half. Cos x equals a half sine x. Right, we have an LCD of 2, so I'm going to multiply through by 2, which will give me root 3 sine x plus cos x equals sine x. Right, I have like terms, so I'm going to take this sine x across to that side over there. So I'm going to be left with cos x equals sine x minus root 3 sine x. Right, so cos x equals, take out a common factor of sine x, and I will be left with 1 minus root 3. I'm getting there. I can see I'm getting towards my answer. I need to get a tan. In order to get tan, we have to divide both sides by cos. And that cancels, so we'll get 1 equals, I would rather write this in the front, 1 minus root 3, and sine on cos is tan x. And then I end up with tan x equals 1 on 1 minus root 3, and I have achieved the answer they told us we should get. Right, that was a very nice one. Right, evaluate means you've got to finish up with a number, a value. I have a look at 20s and 50s. I don't see a connection directly. I know that tan has to be sine of 20 on cos of 20. So I'm going to change these to co-functions. So I'm going to change sine of 50 to cos of 40. And I'm going to change cos of 50 to sine of 40. And I'm going to change tan to sine 20 on cos 20. Right. Now, sine of 40, I'm going to use this sine formula, and that will give me cos of 40 plus sine of 40 is 2 sine 20 cos 20 times by sine 20 on cos 20. Right, and then these cancel, cos of 20 with cos of 20, and we are left with cos of 40 and 2 sine squared 20. Right, so I'm going to take the cos of 40 and I'm going to use this formula here to do. Cos of 40 will be 1 minus 2 sine squared 20 plus 2 sine squared 20, and those two add up to 0 and I'm left with 1. Right. The next question. If sine 61 degrees equals root A, evaluate cos 15 cos 73 plus sine 15 sine 73. All right, well, this here is your compound with a plus. Compound cos with a plus is this one over here. Right, so bringing that down, we're just going to make cos 15 cos 73 the cos with a minus. The minus, the order doesn't matter for cos. 15 minus 73, and that will give me cos of negative 58. Right, and cos of negative 58 is cos of a negative acute angle, so it's in the fourth quadrant, and cos in the fourth is positive. Right, so let's just write in here that this negative here makes it fourth quadrant, and therefore the cos in the fourth becomes positive. Right, so now I don't see a relationship between cos of 58 and sine of 61. So what I usually do is I go and do the compound angle, which is going to be 90 minus 61 is 29, and that will also be root A. So those are the same, and now I see a link. 29 is half of cos of 58. So let's continue over here. We're going to make that cos of 2 times 29, which is 2 cos squared 29 minus 1, and that will be 2 in place of cos squared of 29. We can put in root A minus 1, and that is squared, so your final answer is 2A minus 1. So that one is actually very nice. Just watch what I did up here in red, please, and also watch this fourth quadrant angle. If you don't like that method, add a whole revolution onto the negative and go and work with your cast diagram. Right, when I see this, I see that we have to do Pythagoras, and that is supposed to be 90 degrees, apologies. We are in the first quadrant. So 3 cos theta equals 1, cos theta equals a third, and we have to be in the first quadrant. Right, so this is theta. Cos is adjacent over hypotenuse, and if you do Pythagoras, you will get root 8, which is 2 root 2. And please write Pythagoras, they will want to see that. Right, so now we're going to bring down this cos of 90 minus 2 theta. So cos of 90 plus 2 theta, let's make it a plus. 90 plus 2 theta is going to be a cofunction. So cos will change to sine 2 theta, and 90 plus is the second quadrant, and cos in the second quadrant picks up a negative. Right, I cannot work off this diagram because I have a 2 theta angle and my diagram is a theta. So I'm going to now go and do, that is minus the double angle, 2 sine theta cos theta. Bring down the minus, and the 2 sine theta is 2 root 2 on 3. And cos of theta is 1 on 3. Right, so as not to squash it in too much, that's going to give me negative 4 root 2 on 9. And that's it. Right, apologies about that there, please. I wanted it in the first quadrant. That's it, and I hope you found this lesson very helpful. Please subscribe to get regular updates on future videos, and leave a like and a comment. And if there's something in particular you'd like me to cover, please let me know. And please share with anybody out there who you think would find these lessons beneficial.